Today we will be covering the necessary functions to complete problem set 4, and as usual the notes for this assignment and the notes for the functions that I will show you can be found on my GitHub at this following link, which is uploaded here. But today I will just show you how to do the assignment through RStudio. So let's go ahead and download the data for problem set 4. It's going to be from this PS4 data.csv. So let's import that. And you can see here it's successfully imported. Let's maybe check out the first couple rows of the data set just to see what kind of data it is. So let's use the head function as usual, and we can see here that we have age, father's education, education, and log wage. Now we will, as usual, be importing the dplyr package, so the install.packages, dplyr, and after that's been done, you can run this, and then the dplyr functions now will be available for us to use. Now, the first part of the assignment asks you to make a standard error calculation. So I will go kind of a little bit painstakingly through the calculation just to make it a little bit more clear what it is we're actually doing when we calculate the standard error, and for a brief refresher, standard deviation. So what I will first do is use the dplyr function called select and just take one column called education. So I will run this line of code just to show you what it does down here in the console. And what that does is creates a new data frame with only the education column. So that's what select does. It selects one column. So if we run this line of code here, you will see that we now have a new data frame called df_ed. And if we want to take a brief look at it, we can. And what you'll see is there's just one column. And now we will use that data to calculate the standard deviation. So what we're first going to do is add another column to the data frame called mean. And so what that will do is on the left side, we'll create a new column called education mean right here. Again, this could be titled whatever it is that we want because it's on the left side. You got to have an equal sign. All of these have to be connected. And then what we're going to do is just calculate the mean of the data we have in df_ed in this data frame. So the df_ed is the name of the data frame, and then educ is the name of the column. So in order to access this data, we need to type the name of the data frame, and as usual, the $sign followed by the name of the column. So that's exactly what we have inside this mean function. And what you'll see here after it runs successfully is that if we were to look at the data again, what you'll see is that the mean has been successfully calculated. Now we can also look at it with the head function, and that shows that we have now two columns. And after that, what I want to do is calculate the deviation. So it is each observation in the data, so 10, 7, 6, these are all individual observations, minus or subtract the mean, and then square it. So that's how we get the deviation. And again, this is just creating a new column in the df_education data frame that we now have, and the deviation will be the name of the new column. So we'll run this, and we'll run the head function, and what you'll see now is that we have a deviation column. Now what you'll notice is that for the mean, we don't have any change, of course, throughout the whole data, but for the deviation, what we're actually doing is taking this left side data here in the education column, subtracting this data here, and then squaring it, and then that is what this column is. And this should make a little bit of sense because for example, in the first observation, education level is 6 and the mean is 7. So there's not very big of a difference between the two, and thus the deviation is quite small. However, when you look at this person who has the education of 3, they're quite far away from the mean. So once we subtract 7 and square it, we have 16. So I hope that makes a little bit more sense about how to calculate the deviation. And we'll continue to go along here. Now, what now we want to do is to sum the deviation. So we're going to create a new column called xi sum within this data frame. And we're going to use the sum function. And we're going to use the sum function on all of the deviations that we had calculated. So everything in this column here. So once we run this line of code, what you'll notice is that we have yet another new column. I can, of course, show you it here as well. And this is the sum of all of the observations in this deviation column. Now we are going to calculate n, so the number of observations, and this is quite easy. It's just using the length function in R, and we're doing it on the education data as we have been before, and we're creating a new column, and this column will be called n. It could also become called observations, whatever you want to call it. So doing that, and what you'll notice is now there's a new column called n, and now we can finally calculate the variance and standard deviation. Now, if you remember, the variance and standard deviation is calculated by taking the sum of the data that we just calculated and dividing it by the number of observations minus 1. So we'll run this, and now we have the variance here, and it says it's 8.342, and now we will calculate the standard deviation. So again, we're making just a new column called standard deviation, and we're just going to take the square root of the variance, which is what we just calculated, and it's 2.8. And now we can finally calculate the standard error by taking the standard deviation and dividing it by the length of the data. So that's what we're going to do right here. And that's our standard error. And now we will check whether our answers are correct. And so we can do that with the variation, with the length function, with the variation function, with the standard deviation function. So when we run all that, we can check that indeed the length is 741, the variance is 8.3, and the standard deviation is 2.88. Now you don't need to understand exactly what I did here. This is just an example to show you how to calculate the standard deviation and variation by hand. But of course, you can always use these really useful functions that we have built in as well. So this was just for an example above. Now we can go into the confidence interval calculation a little bit. We have actually already gotten closer to solving the confidence interval by calculating the standard error. And however, we still need to get the t-score because I will just show you this very briefly here. In order to calculate the confidence interval, the formula is here. It's the mean plus or minus t score times multiplied by the standard deviation divided by the number of observations, the square root of the number of observations. So that's the calculation. So we have now we have now S, and we have now X, and we also know N, but we now need to get T. So the way we can actually find the T distribution is by using R, and the function is Qt. And if we want to find the 95% confidence level like we do for the problem, we actually, it's not very intuitive, but you need to type in 0.975 here, and then you type in the df and the length of the data that you're putting in the -1. So if you run this, you'll see that our t-score is 1.9631, and if we want to now calculate the confidence intervals, we take the standard error. So if you were to just type in df_ed standard error, what you would notice is that there's many different observations for standard error. We just want one of these, so in order to do that, all you have to do is put a 1. If you ran that, it would give you a lot of output, but we just want simply one observation. So if you put a 1 next to it in brackets, you'll notice that it actually just outputs 1. So that's all I'm doing here in this line of code. And so I save that. As you can see now, I have the standard error saved up to the top right, as well as the t-score that I ran here. So just check to make sure that it came up here. And then the confidence interval is relatively easy to calculate. You just multiply the t-score by the standard error. So that's the confidence interval, and you can see it right there. And then I just want to take the mean. So this is the x portion of the formula right here, and now we more or less have all of the necessary data. Now we just need to calculate the confidence intervals. So let's just label everything just to be clear. This is the standard deviation we calculated above. This is the confidence interval. This is our mean of the data. And then this is the actual calculation right here. So this is the lower bound. It's x mean minus confidence interval. This is the lower bound. And the x mean plus confidence interval will be the upper bound. Now we can run this. And we can run this. And if you want, you can even save that for good measure. Lower bound, upper bound. And what you'll see now here is that we have that data saved. So if we wanted to see it, now that it's saved, all we'd have to do is type it in, run that line of code, and it would spit out the answer. So that was a lot to cover. I can elaborate on this further in the next video, but please attend my office hours if you have any questions regarding the calculation that I just did. And now we will move on to t-tests. So this is corresponding to 1B and 1C. What I did above was corresponding to 1A. In this part, we will actually be using the MT cars dataset. So if you want to check out that dataset, I think you've seen it before, but again, it is different types of cars with different specs on each car. And we will want to run a t-test on some data here that we have. So I just randomly chose the miles per gallon column. You could choose whatever for this t-test. For your assignment, I believe you are using the t-test on education. And so for the t-test, you put the data in the first part of the function, and then you put the mean as mu equals whatever number mean that you're trying to test. And when you run the function, what you'll see is this output here. So what you'll notice is that we rejected the null hypothesis that the mean is equal to 15. So the alternative hypothesis is true, or there's evidence for the alternative hypothesis, excuse me. And you know that we can reject because the t is huge, it's 4.7, and the p-value, this is actually scientific notation, but this is almost close to 0. And it also gives you the confidence intervals and, of course, the mean. So this actually makes sense because the mean of MT-CAR's MPG, so the MPG column, the mean is 20. So it's not very likely that 15 could be potentially the population mean, given the fact that it's quite far away from 20. However, that doesn't necessarily mean that it's not. Just to be clear, if the calculation for the t-test, I think you'll go over in class, but sometimes you can kind of eyeball it to understand whether it seems to be a statistically significant different mean. So now we will go over the two-sided t-test, and we are going to compare actually two different means for different cars. Sticking with the MT-CARS example, we are going to compare automatic and manual transmission, the weight of the cars, to test whether the weight of the cars is actually different. So the first step is to filter the observations for automatic vehicles. So I do this with the dplyr, so MT-CARS, and then I use the filter function. The AM is the, I think, type of transmission, and equals to 1. And then I select the weight column. So I run this line of code, and what you'll see is that there is another data frame that was created. And if you wanted to check it out, it's not too many observations, and these are just the weights for all of the automatic vehicles. And again, in order to save a new data frame, we need to create a new name and do the equal sign. If we didn't have the new name and the equal sign, and you ran this line of code, what you'd notice is that it would just come out on the bottom. Okay, so we were successfully able to select the automatic vehicles. Now we want to select the manual vehicles, and it's MT-CARS, dplyr function filter with a transmission. So AM is actually a name of a column. I'll show you that here quickly. AM is just the name of the column, so AM equals to 1, you're grabbing every row with a 1. AM equals to 0, you're grabbing every row with a 0. You can also filter other columns too, so gear, carb, VS, whatever you want it to do, but in this one we're filtering for automatic and manual, so we use the AM column. Now we'll run this line of code, and what you'll see is that there's another data frame here. It's called WT manual. And now that we have the two data separated, we can do the t-test. So this time it will be t-test, and then the first set of data, the second set of data. And I actually save this output. So what I showed you here is t-test, and the output just comes out automatically. You can also save this, save data. I won't save it now, but I can save this one. So it's the same exact idea. You run the t-test. This is the two-sample t-test, and what you'll notice is that the t-score again is very high, so we can reject the null hypothesis, which means that there's evidence that the means are actually different, which actually makes sense, right? cars that are automatic and manual might have some differences in their weight that can be attributed to the way the cars are built or whatever reason, but it would make intuitive sense that they could potentially be different. If I wanted to save this output, I could just save it like I do data frames or any other object, and that test solution data will actually be here. And if you wanted to see it, you could just run it and it would come out like that. Now, the reason I actually save that is you can extract certain data from here. So you can extract the T, you can extract the degrees of freedom. That's what df is here. It's not data frame. You can extract the p-value. So once it's saved, you can just extract that data. So what I do here is I take that test solution data that I saved, and I, exactly like selecting a column in a data frame, I use the $sign. But this time I type in p-value, and that, if you run it down here, for example, you'll see that the p-value is printed, and it happens to be, luckily, the same exact p-value that we see when we run the entire output. So let's do that, and now that p-value is saved somewhere here. And what I'm doing here actually is something I like doing for statistics class. When I'm using R, I use if. I could have used an else as well, but just for the example, what I'm doing here is, and this is kind of optional, so I'll make this very clear. Optional if statement. Let's do this. And what this does is it has this p-value, which is actually this really small number. And what I'm telling this to do is, if this p-value is below 0.05, what that means is we have rejected the null, and it means that the evidence that the means are statistically different. So it's just a very clear way to interpret our data when I use if statements. So I'll run this line of code, and what it does is actually it prints reject the null, and this next line it prints this, so the functions that were inside. And if this were not under 0.05, this would not print. So if you run this second line of code down here, if p-value is bigger than 0.05, which in this case it's not, we print failed to reject the null and no evidence that the means are statistically different. So it's a different interpretation, and I run that line of code, and you'll see is nothing prints. So that's, I should have probably introduced you to what if statements are beforehand, but I just wanted to give you a quick introduction to it here and its application. So I can, just to give you a simple example really quickly, I'm going to define x as 5. So x now is saved as 5. And if x is greater than 2, what I'm going to say is print bigger than 2. And you should try to stop the video and guess whether this will print or not. What I'm saying is, oh, x smaller than 2, excuse me. And what you'll notice is that nothing printed out. But if we were to switch the sign, because the x is 5, and we were to say bigger than 2, and we were to run the whole thing again, what you'll notice is that it actually does print. So there's a lot more you can do with if statements, but I like using it for data interpretation in R. So again, just go over this if it's confusing. Now we're moving on to problem 1F. We're doing a one-sided t-test, and we are again using the same data that we used before, but this time we're using this alternative attribute within this t-test function, and we're saying less, we're writing less, or you could say greater. and it becomes a little different to interpret, so be careful. And I believe that the professor will go into greater detail about what this means in the lecture. I will follow up in a subsequent lecture about the difference between these two, but we're getting a little long here in the video, so I wanted to not dive too far into this topic before the professor does, because I know he will be doing videos about it as well. And now, this last part is also optional, like this if portion. This will be quickly covering functions, and you might think, well, I use functions every single time I use R. I've learned the head function. I've learned the mean, the standard deviation, right? There's all these functions that we've used until now. Well, you can actually write your own functions as well, which happens to be incredibly useful when you are doing data analysis. And I actually use it quite a lot. I'm just going to introduce you to the very basics at first. So when you write a function, you always name the function. So I'm calling it first function, and you always use the equal sign. So it's exactly like you save any other R object. And then you always write function, so this doesn't change. And then inside that function, you put your inputs. So in this function, we have two inputs. What I call it is A and B. You could call it X and Y. You could call it whatever. You could call it column. You could call it row. For this example, I will just use A and B. And then you use these kind of curly brackets. And then that inside will be how we calculate our function. So I'm just doing a simple addition. So A plus B, and then I'm saving it as an answer, and then return. Answer outputs what we want. You could also put print if you wanted. So print you could use, but when we're writing functions, usually we use the return function. So this is just stuff you have to kind of remember, this function jargon, function and return. But what is important to really understand is that the first part on the left-hand side is just the name of the function. This will always be written function, and then inside are the inputs, and this could be whatever. So let's actually save that function as first function by highlighting it all. And what you'll notice is that now there's this function little tab here, and what you notice is that we have our function saved. So what we can actually do is, just like mean or head or any of the other functions, we take the name of the function, we use the brackets, and then we put in our inputs. So A equals 2 and B equals 3. So if I run that, what you'll notice is it's just simple addition. If I wanted to make it multiplication, all I would have to do is go back up into the function and write a multiplication symbol, run the function again, because we need to save that new functionality, and then we run the first function again, and what you'll notice is it actually multiplied. So that's the very basics of functions. I like to use it to interpret data, and one way I do this is actually by putting in data. So I will label this column. So again, this could be labeled A, B, whatever, in order to input this column data that I'm going to put in down here. And then I am summing the data and saving it as a data called answer, and then returning that answer. So again, this could also be called, sum of data. Like anything in R, when you save it, you need to actually not have any spaces, so that wouldn't work, but this could be named whatever, just as a heads up. So it's just called sum column. Again, this is the name of our function here. I'm saving it. What you'll see is that the sum column is now a function that we can use. So again, exactly like head, mean, whatever functions you've been using, histogram is a function too. We just type in the name of the function, so sum column, and then in that we're just going to put in our age data, and what you'll see is that it just gives you the sum of all of our ages, which seems kind of useless, but I will extend this in the function below. So I will call this function down here called summary stats, and again, we're doing the function, and I'm putting in this column data, and I will create a sum, a mean, and a standard deviation output, and then I will print all of that. So print here rather than return. And what you'll notice is there's this paste function also as well that I have here. And what that allows you to do is put text with saved data. So this sum, mean, and standard deviation will be printed out along with this alphabet here on the left side. Sorry, I couldn't think of a better word to say. So we'll say the summary stats function, and then we will type summary stats and put the name of our data in, and then voila, when we run it, you'll see that there's a sum, a mean, and a standard deviation. And what I wanted to show you, what I was working up towards, was how you can calculate a standard deviation in a function yourself, or a standard error or confidence interval. So this standard error has the n, the sum of the differential, the standard deviation, the standard error. It's exactly in the format that I showed you above, but just in a function this time, rather than typing it in one by one. So I will use the standard error function by running this whole entire portion of code, and then I will show you that the standard error, if you type it in down here and you put in some data, what you'll notice is that you get a standard error calculation, which I believe if you go back to number 1, it is exactly the same. So it's kind of nifty. Again, you can just check your answer by taking the standard deviation and square root, and what you'll see is that it looks like we calculated correctly. For confidence interval, it's really nice because if you remember back in the first example, it's a little difficult to calculate by hand, but what this function does, confidence interval I call it, what this function does is just calculates it for you and spits out the data that you want to see. So again, we're going to put in this column data, and then I also include what's called the confidence interval, or I call it the confidence interval. This again could be written X, this could be, you know, anything you want to title it. This could be anything you want to title it, and again, the title of the function could be anything you want to title it. I'm using the same exact kind of structure as I used above here in 5.3. So I will calculate the length, the sum of the differentials, which will lead me to the standard error calculation, and then I will do the t calculation here, and qt is the function, of course, for the t statistics that we used earlier, and whatever confidence interval that we type in here as an input will actually be input here specifically. You'll notice that this column that we type in here will be input many times, right? You see that? And so this function will go on to calculate the t statistic, and then what I have it calculate is the final the solution, and then the mean, and then I have this confidence interval for the lower and upper, and then it will be printed out. And so I will show you what this looks like after I save this confidence interval function, which you can see here. And then all we have to do now, rather than calculate it all of ourselves, all we have to do is type in the confidence interval, the data, and then the confidence interval that we want to see. And let me just clear out the data just to show you what the output is. So it shows you the mean plus or minus the confidence interval, and then the upper bound and lower bound calculation. And the nice thing about functions that I think you have come to understand is that you can, once you have it, you can use it over and over and over again. So if we had a different data set, if we wanted to see, go into our data and see some other columns, so the log wage, for example, we could just put that in there, log wage, and we could see the confidence interval for that as well. So you could use it for any data, and it's reusable, and that's why functions tend to be quite helpful. So that was quite a long video today. The end was optional. The beginning, so number 5 was optional, everything in 5. The number 1, the first example, if you didn't understand it, don't worry too much about it. It was meant to be an example of how to calculate the standard error and standard deviation again. And as usual, if you have any questions, please email me or come to my office hours on Thursday. Anyways, I hope everyone did good on the midterm, and take care.